We are going to study the Montecarlo analysis. In this analysis, we are going to study how to prepare the circuit. In the capture window, go to File and select the new project and name the project as MC Cascode or My Cascode, and in the location, browse and select the drives as C, then click OK. In the capture, this is the schematic diagram of My Cascode. Go to the place and part and click the variables and make sure the display property of CTOL is set to 10 and LTOL to 10 and RTOL to 10, either of this, and click on the R3 resistor and make sure the display properties of negatol is set to 20% and postal to 20% and the display property to Gauss 0.4. In the capture window, now we are going to set the simulation profile. In the PSpice, select the new simulation and give it as a DC and create. In the create AC analysis, select the DC type and the sweep variable as V3 and value list set to 0 and click OK. Similarly, set the AC simulation profile. Create the new simulation and name it as AC and click create. In the AC simulation settings, make sure the analysis type is AC sweep, and AC sweep type starts a frequency from 1 MHz to 600 MHz and the points of decay to 100, and click OK. We are going to self-check runs and using measurements. The warnings are verified and we are going to run the AC sweep. Once in the AC sweep, in the capture, select the view measurement profile, and in that we are going to evaluate the cutoff low pass of 3 dB frequency and select the V out and click OK. The value is displayed for the measurement cutoff low pass. Similarly, evaluate the maximum of VDB out . Okay, we can see the values for these measurements. We are going to see the graph and trace the maximum of VDB of, not the maximum, VDB of out in order to see the graph, and click OK. This is the required graph of VDB out. Now we are going to run the DC sweep. As earlier we have created the DC sweep profile. In the DC sweep simulation settings, we have already given the name as V3 and the value list to 0. In this, set the measurement settings, results, and trace the equation of power consumption of transistor Q1 and click OK. This is the value of the measurement for the power consumption. Similarly, add the measurement for the collector current of Q1. We are going to see how to run the Montecarlo. In the capture, go to PSpice, select the advanced analysis and click Montecarlo Now the Montecarlo window appears. Now click here to import a measurement created within a PSpice and select the required measurement and click OK. This is the graph how it look like. Go to edit and select the profile settings and make sure the number of runs is set to 100 and click OK. We are going to run the Montecarlo. Go to run and start Montecarlo analysis. Once the Montecarlo analysis is run, we can see the different graphs for the measurements which we have been selected. This is the PDF graph for the cutoff, low pass, and this is the maximum and power and the current of the PDF graphs. We can change the PDF graphs to CDF graph by right clicking the PDF graphs, and these are the different graphs. CDF graphs, that's cumulative distribution graphs for cutoff, low pass of 3 dB measurement. In order to change, we can right click and select the PDF or convert it to CDF, either of the required. We can set the maximum and the minimum for the low pass frequency. We can see the changes once we move the cursor of the maximum. Right click and make sure it's set to probability density graph. This is the maximum one for the measurement of cutoff low pass. The minimum is 0 for this graph. Now we can go to edit and change the number of runs to 25, and we can see the changes in the PDF graph. Once we change the number of runs to 25, we can change it to the either CDF graph or PDF graph. We can see the same graph for the number of runs to 25 for the maximum of VDB of out. Once it's done, we can close the and zoom into the resistor R3 and in the capture and set the R3 value to 5K and click OK. Once it's done, it save the project or save the design. In the capture, go to select PSpice and advanced analysis and Montecarlo. The Montecarlo window appears. This is the Montecarlo analysis. We are changing the PDF to CDF graph. These are the different graphs for the different measurements of collector current of transistor Q1 and the power dissipation of Q1 and the cutoff low pass frequency and the maximum of V out. We can see the different CDF and PDF graphs as shown here. This is the collector current of Q1 transistor of CDF graph. We can change the maximum. We can set the location of maximum. Once it's done, we can close the advanced analysis of Montecarlo window and save the design if required, and close the capture window.